It's a lovely Sunday morning and you decided to make your monthly trip to DMart. And as soon as you entered, you went directly to the beverages section and you grabbed your favorite coffee powder. But when you were leaving with all of the other stuff, you realized that you've bought a packet of Maggie too. But you decided to be healthy this month. How did this happen? Is someone spying at you? Is that how that packet of Maggie ended up in your trolley? Well, maybe, but not completely. So this time again, there is another machine learning algorithm that is behind all of these impulse purchases of yours and that is making you spend extra money in supermarkets and during online shopping. So let's get to know what this algorithm is better. Hello everyone and welcome back to my YouTube channel. I am Selina and in this week's video, we are going to understand the intuition behind Apriori algorithm. We'll ask more and more complex questions as we move forward in the video, and we'll end the video with a Python implementation using scikit-learn. So let's jump right in. Let us first break the ice on how you ended up buying Maggi noodles along with coffee powder. So the magic behind this unplanned purchase is something known as market basket analysis, which is powered by the Apriori algorithm. Retailers like DMart and Walmart use these algorithms to understand shopping patterns. They analyze tons of data to understand which customer would like to buy what product along with another product. In your case, the algorithm understood that if you want to buy something like coffee, you might also want to purchase instant noodles for the days when you're extra busy and don't want to spend a lot of time in cooking lunch. This algorithm isn't just about data. It is a classic example of how retail stores like DMart and Walmart use subtle strategies and use complementary products and place them next to each other to increase impulse shopping. The a priori is a fundamental algorithm in data mining that is used to identify frequent item sets and also their association rules. You will be amazed to know that this algorithm was introduced by two Indians, Rakesh Agrawal and Ramakrishnan Shrikant in 1994. It was a part of their research paper titled Fast Algorithms for Mining Association Rules. Before this algorithm, discovering frequent patterns in transactional data was a time-consuming process. And as the size of the dataset grew, it became more and more impractical to find such item sets. The a priori algorithm automated this process, making it significantly more efficient and scalable for very large datasets. Let us now understand the key concepts involved in the a priori algorithm in more detail. Imagine you have a grocery store and you want to know what items people often buy together. The a priori algorithm helps with this by analyzing transaction data, like customer 1 buys milk, bread, and butter, customer 2 buys milk and bread, customer 3 buys bread, butter, and customer 4 goes for milk and butter. Based on this, the a priori algorithm will try to find out which items appear together more frequently and which ones are the most popular combinations. First up is item set. An item set is simply a collection of items that are frequently bought together. From our previous example, we can see that the item sets here are like bread, butter, milk, or bread, butter. So these are all frequently bought together. Support is a measure of how frequently an item set appears in a data set. In simple words, how common is this item set across all transactions? The formula for support is number of transactions containing item set A upon the total number of transactions. For example, if milk and bread appear together in 3 out of every 5 transactions, then the support for milk bread item set is 3 out of 5, that is 60%. This means that the 60% of the transactions in the dataset contain both milk as well as bread. Our third term is confidence. So, in formal words, confidence is the likelihood or probability of buying one item given that we have already bought another item. The formula for confidence is the support of A intersection B upon support of A. Here, A arrow B represents a rule. For example, if a customer buys milk, they will also buy bread. The support of A intersection B is the support for the item set containing both milk and bread. And the support of A is the support for the item set containing only milk. For example, The support for the item set milk bread, that is containing both milk and bread, is 3 out of 5, that is zero point 0.6 as we have seen previously. And the support for the item set milk only is 4 out of 5 or zero point 0.8. Then we can calculate the confidence by this formula, zero point 0.6 by zero point 0.8, that is 0.75. This means that 75% of the time when a customer buys milk, they also end up buying bread. It tells you how reliable this rule is in terms of predicting the co occurrence of items. Finally, we have lift. It is a measure of the strength of association between two items. Simply put, it tells us how strong or weak the relationship is between the different items of an item set. That is, if you're buying it accidentally or you're buying it deliberately because you want to buy these things together. The formula for lift is the confidence of item set A to B upon the support of B. Here, confidence A to B is the likelihood of B being purchased when A is purchased, and support of B is the probability of item B appearing in the dataset. If we continue with our previous example, the confidence of milk to bread was 0.75 and the support of bread was zero point 0.8 since it appears in 4 out of every 5 transactions. Now, if we calculate the value of lift, we'll get 0.75 upon zero point 0.8, which is 0.9375. A lift value of less than 1 means that the two items are less likely to be bought together. And if it is greater than 1, it means that they are more likely to be bought together. In our case, the lift is 0.9375, which indicates that milk and bread are slightly less likely to be bought together. These three metrics are the heart of the a priori algorithm. So, for example, if the support, confidence, and lift of milk and bread are really high, then the store might place milk and bread right next to each other to increase the chances of them being bought together. Finally, let us take a look at a Python implementation of the a priori algorithm on Google Colab. We start by installing the necessary library, that is MLExtend. Here we are not using scikit-learn because it does not natively support the a priori algorithm. Next, we import the necessary libraries, pandas for data frames, then there is a priori and association rules from MLExtend. Now we create a sample transaction data set. Here each row represents a transaction and each column represents an item. The number 1 means that the item was bought and 0 means that it wasn't. We then convert the data into a pandas data frame using pd.dataframe. Here, as you can see, milk, bread, butter, and diaper were bought in the first transaction. In the second one, milk, butter, diaper, beer were bought, and so on. Over here, only the first 8 are displayed, but there are multiple more transactions. Now, we create a variable frequent item set using the a priori function on the data frame that we just created. Here, min support zero point 0.3 is used. This means that we only want to filter out the transactions in which the support was more than 30%. Now we display the frequent item sets based on our previous filtering. So as you can see, the support for individual item sets like milk, bread, butter, diaper, beer is quite high, like 0.75, 0.875. Then we have the combinations like milk bought with bread, milk bought with butter, or bread bought with butter. Later, you can also see that there are three items like milk, bread, and butter. Now we develop the rules using association rules on our frequent item set that we previously created. Here we are using the metrics of confidence and setting a threshold of zero point 0.7. This means that we only want those item sets from this frequent item set data set that contain a more than 70% confidence rate. Here we have printed the association rules. You can see that the confidence in all of these rows is greater than 70%. And we are also displaying the support and lift for all of them. Here, 0, 1, 2, 3, 4, all of these are the transactions. Finally, we can develop an even stronger rule by using a lift greater than 1 because we already know that the value of lift greater than 1 means that these item sets appear more frequently together.
So here you can see we have filtered out the transactions. We can't see 0, 1, 5, 7. This means that all of these transactions are the ones which occur the most frequently together. And these can be placed together in a market or a supermarket or store or something like that.
This algorithm is a part of unsupervised learning, which is a type of machine learning where the algorithm is trained on unlabeled data. That was all for this week's video. I hope you enjoyed it and got to learn something new this week. And if you did, then don't forget to like, share, and subscribe. I'll be back next week with another intuition behind another machine learning algorithm. Till then, thank you for watching and see you later.